Okay, this is FRQ set 6, number 3. We're on to series and sequences here, right? So this says let f of x equals natural log of 1 plus x cubed. Part A says the Maclaurin series for natural log of 1 plus x is given here. Use the series to write the first 4 non-zero terms and the general term of the Maclaurin series for f. So this is really nice because it's already set up some of the terms for you, so you can use this to manipulate and get our new function. Right? So the only difference from this and our new function is that the x now turns into x cubed. So that means then what we need to do is just plug in x cubed into each of the x terms. So then it will become x cubed minus x to the 6 now, right? And then x cubed cubed, so x to the 9, and then x to the 12. So you can see nothing's changed except the power of the x, and it's going up by 3s. So then our general term is going to be x of 3n, because it's in powers of 3 or multiples of 3, and then over n, right? So that will be our first 4 non-zero terms and the general terms. Okay. Part B says the radius of convergence of the Maclaurin series is 1. Determine the interval of convergence. Show that the work that leads to your answer. So it already told you that the radius of convergence is 1. That means the absolute value of x is less than 1, right? We know that already. So that means that x is between 1 and negative 1. So our job here is to actually look at those endpoints and see if they converge or diverge. So just like what we did before, we're going to plug in x equals negative 1 and plug in x equals 1 and see if they do converge at those endpoints. So if x equals negative 1, then my summation, my series now become negative 1 to the n plus 1, negative 1 to the n over n, right? So that makes it that, sorry, oh, wrong one, the new one, sorry, there's 3n on top, not n. I'm looking at the old one, 3n. So that makes it negative 1 to the 4n plus 1 over n. 4n plus 1 still makes it an alternating series because it's still going to alternate the positive negative. Well, pause. It's going to make it negative because 4n plus 1 is going to make all my powers odd. So odd power making this negative. So this is going to be just simplified to negative 1 over n, which is a diverging p series or harmonic series. So this is going to diverge. So diverge. So not this one. The other endpoint, x equals 1, let's plug it in. We get negative 1 to the n plus 1, 1 to the 3n over n. And we know then that's negative 1 to n plus 1, and then that 1 over n, right? Because 1 to 3n doesn't really matter, it's just 1. So this is going to converge by alternating series test. So this endpoint is going to converge, right? Because if we do, sorry, my limit as n approaches infinity, 1 over n equals 0. So this is going to converge by alternate series test. Therefore, my interval convergence is going to look like this, where it's non-inclusive of negative 1, but inclusive of 1, like so. Okay. All right. Part C says write the first 4 non-zero terms of Maclaurin series for f prime of t squared. If g of x equals the integral of 0 to x of f prime of t squared dt, use the first 2 non-zero terms of the Maclaurin series for g to approximate g of 1. Okay, one at a time. We can find f prime of x first, then we'll plug in the t squared. So that will be a little bit easier, right? So f of x is already defined up here in part A. This is your f of x, right? This is f of x. So let's do f prime of x. That will give us 3x squared minus, drop down to 6. So that's 3x to the 5th plus 3x to the 8th minus 3x to the 11th. And you can see it's all 3's. Pretty good. Okay, and it says find the first 4 non-zero terms. Okay, I already have first 4 non-zero terms. Awesome. Now I'm going to plug in the t squared. So just like before, we're going to manipulate this into the t squared 1. So that's 3t to the 4th minus 3t to the 10th plus 3t to the 16th minus 3t to the 22. Okay, and then now it says if g of x equals the integral of 0 to x of f prime of t squared dt, right? So g of x equals integral 0 to x of this f prime 3t to the 4th minus 3t 10 plus 3t to 16 minus 3t to the 22nd dt, like so. Okay. All right. So then it says g of 1. So g of 1, that's what we're tasked to do. That means 0 to 1 of this integral. And now it says only use the first 2 non-zero terms to find this integral. So we're actually cutting our work down a lot, right? So t to 10. So that will give us 3t to the 5th over 5 minus 3t to the 11th over 11. Integrate from 0 to 1. Don't worry about the 0 because this is a polynomial function. 0 equals 0. So we have 3 to the 5th minus 3 to the left, 3 over 5 minus 3 over 11. That will give me my crisscross, 33 minus 15 or 55. 18 over 55 will be my G of 1 value. Okay, last one. The Maclaurin series G evaluated at x equals 1 is a convergent alternating series. Oh, keep in mind it's alternating series with individual terms that decrease in absolute value to 0. Show that your approximation part C must differ from G of 1 by less than 1/5. Because this is an alternating series, my error is just the next term, right? So next term is right here, 3t to the 16th, and we're taking the integral of that. So that will be 3t to the 17 over 17, right? And we're going to plug in 1, x equals 1. This is my error. So my error is going to be 3 over 17. That is definitely less than 3 over 5, 3 over 15, which is the same as 1/5. So this is going to prove the fact that the difference is less than 1/5. Okay, all right. Okay, so this is set 6. We're on number 4 here. It says the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the closed interval between 0 and 8. The graph of f prime has a horizontal tangent at x equals 1, x equals 3, x equals 5, which tells me these are kind of our my, max, and min points, but with different ideas that we're going to work with. The areas of the region above of f prime and x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies that f of 8 equals 4. Okay, beautiful. Find all values of x in the open intervals, which function has a local minimum. Justify your answer. So this is f prime, right? To find a local minimum, a minimum needs to go from decreasing. So part A, we want a minimum. Minimum must go from decreasing to increasing, which means f prime must go from negative to positive. So where did it go from negative below the x-axis to positive? Right here. That's the only point where it went from negative to positive. Okay, so you will say it has a minimum at x equals, that would be 1, 2, 3, 4, 5, 6. X equals 6 because f prime is less than 0 for x is less than 6, and f prime is greater than 0 for x is greater than 6. So that's how you justify. You show that it was negative below 6 and before 6, and it was positive now after 6. So you went from negative to positive, hence you have a minimum here. Okay. All right, part B says, determine the absolute value minimum of f on the closed interval between 0 to 8. Find, justify your answer. So because it's a closed interval, we found the minimum from before, but that could be a local minimum. So we got to check our endpoints to see where we can find an absolute minimum for this one. So you have your x and your f value, right? Well, our closed interval is from 0 to 8, and we found a minimum at 6. So you got to find all the different values that of f and see which one is truly the lowest to get my absolute minimum. So this is where this comes in. F of a equals 4. That's kind of like your initial condition, and it tells you that's kind of where you start in terms of figuring out what your f is. So your f is defined like so. Your f is defined as the 4 because that's your starting point, and then the integral starts at x equals 8 to whatever x value you want of f prime. So again, that's how you read that initial value and put it into this equation to define your f function using this f prime. Right? So if I want f of 0, I'm looking at 4 plus 8 to 0 f prime. Well, 8 to 0 doesn't help. I want 0 to 8 for that, right? So 0 to 8, that will change that into, and sorry, I don't have a lot of space, so you might have to just kind of squint a little bit. But, excuse me, it'll be 0 to 8 up here of f prime. So the area from 0 all the way to 8. That area would be 2 plus 6 minus 3, because 3 is below the x-axis, and then plus 7, right? So that would give me 2 plus 8 is 2 plus 6 is 8, 8 minus 3 is 5, 5 plus 7 is 12. So that would actually be 4 minus 12, giving me a negative 8 for the first value, okay? All right, what about 6? 6 is going to be 4 plus the integral from 8 to 6 f prime. So again, because it's the wrong order, it's going to want 4 minus 6 to 8 f prime. Well, from 6 to 8 is 7, so 4 minus 7 will give me negative 3. Okay, so far I already know then I see one number that's lower than negative 3. So that 6 is not my absolute minimum. Okay, the last one will be 4 plus the integral from 8 to 8 of f prime. Okay, Well, at 8 to 8, that means there is no interval, right? So that is 0. So that means the answer is 4. So we can see the lowest value truly is negative, oops, I erased it. The lowest value is truly negative 8. So it will be where my absolute minimum will be. So you will say absolute min, look at my answer, right here. Absolute min of negative 8 at x equals 0. Okay, so that will be for part B. Part C, on what open intervals containing 0 to 8 is the graph both concaving down and increasing? To explain your reasoning. Okay, concave down means I want f double prime to be negative, right? So f double prime negative, so let's explain both of this. Concave down, so concave down means f double prime is negative, which means the slope of the graph up there is decreasing, okay? And then you want f increasing. That means I want f prime to be positive. So that means in the picture, I want above x-axis. So you got to look in your picture, which piece is both has a slope of a negative slope and above the x-axis. So I have to look at above the x-axis. So everything above the x-axis, and the negative slope above the x-axis is here and here. So that region is, let's see, 0 to 1 and 3 to 4. Okay, so those are my two regions, 0 to 1 and 3 to 4. So I'm going to write it out, 0 to 1 and 3 to 4, open intervals for these. Okay, all right, last part, part D. The function g is defined by g of x equals cube of f of x. If f of 3 equals negative 5 over 2, find the slope of the line tangent to the graph of g at x equals 3. Okay, so if you want the slope of the line tangent to the graph, so you got to find the derivative, right? So g prime, we're going to look for g prime of this. So g prime, using chain rule, that's 3 f of x squared and f prime of x. Okay, now let's plug in. We have 3 f of 3, because it says x equals 3, f of 3 squared f prime of 3. Okay, it says f of 3 is negative 5 over 2, so negative 5 over 2 squared. F prime of 3, that means I'm looking at the graph. It's the value of 3 on this graph, because this graph is f prime. So the value of 3 here is 4. The y value of 3 is 4. So you get 75 over 4 times 4, which is 75. Okay, that's it.